Hi, this is Dr. Anjaneya Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to discussing about external treatment of water by ion exchange method. So, by using ion exchange method, we can remove the arsenic producing salts from the water. So, ion exchange process is also known as demineralization process. Ion exchange process is also known as demineralization process. Why we should call this is a demineralization process? Because by using ion exchange method, we can remove the minerals. So we know that if you take CaCl2 and MgCl2, CaSO4 and MgSO4, calcium chloride, magnesium chloride, calcium sulfide and magnesium sulfides. These are all arsenic producing salts. So by using ion exchange method, we are going to remove these salts from water. So usually here calcium and magnesium are also known as minerals. So in this method, we are also going to remove calcium and magnesium from the water. So that's why we can call it as ion exchange method is also known as demineralization process. Here we are going to use resins to remove the ions present in the water. So usually water contains different types of chlorides, sulfates, carbonates, and bicarbonates of calcium and magnesium. Here, suppose if you take CaCl2, here Ca plus is the cation and Cl minus is anion. So in ion exchange method, we can remove both cations and anions. So here we have to use resins to remove the ions present in the water. So what is a resin? Resins are cross-linked long chain polymers with microporous structure. So resins are cross-linked long chain polymers with microporous structures. So functional groups present in the resins are responsible for ion exchange properties. Here we are going to use two types of resins, that is cationic resin and anionic resins. So cationic resin can remove the cations present in the water. Like if you take water which contains calcium chloride. So here Ca plus is cation and Cl minus is anion. So cation can remove cations present in the water. Anionic can remove anions present in the water. So usually acid resins which contains acid functional groups. Resins which contains acid or acidic functional groups like COH, SO3H, etc. That resins are act as a cationic resins. Whereas if the resins contains basic functional groups, resins contains basic functional groups that are act as a anionic exchange resins. So here cationic resin is represented by RH. RH. This is a cationic resin. Cationic resin. We can represent it as RH. Why? Because cationic resin is the nothing but the resin which contains acidic functional groups. So let us consider some example. Styrene divinyl benzene copolymers. Styrene divinyl benzenes. We can use as a cationic resins. And sulfonated resins. These are used as a cationic resins. So if you see the structure, the resin which contains SO3H, SO3H functional groups. So it can act as a cationic resin. Whereas coming to the basic resins are anionic resins. So anionic resins are represented by ROH. So resin which contains basic functional groups like quaternary ammonium salts, primary amines, secondary amines, and like that. And styrene divinyl benzene copolymer are amine formaldehyde copolymers with NH2 and quaternary ammonium salts, quaternary phosphonium salts. So quaternary ammonium salts and quaternary phosphonium salts and quaternary sulfonium salts. So the resin which contains these types of functional groups act as a basic resins. So look at this structure of basic resins. So these basic resin or anionic resins can remove the anions present in the hot water. So what type of anions present in the hot water? Sulfur, chlorides, sulfides, etc. And OH minus also. So this type of anions are replaced by using anionic exchange resins. So look at here, this is a cross linkage. So cross linkage structures look like this. So these are the linkages in between the polymeric chains. So this is known as cross linkage. cross-linkage structures. So that is about basic reason. So by using cationic resin and anionic resin, we can remove the whatever cations and anions present in hard water, we can remove. So ultimately we can remove the hardness producing salts present in the water by using exchanges, that is cationic and anionic exchanges. So let us see how we can remove the hardness producing salts from water. These are some examples for cationic exchange resins and anionic exchange resins. So it is a polysterene with acidic sulfonated function groups. These are the sulfonated groups. Whereas it is a strongly basic quaternary ammonium anionic exchange resins. So this one is cationic and this one is a anion. And coming to the procedure. So here operators consist of ion exchange purifier or water softener. So these operators consist of vertical tanks. So there are 4 types of vertical tanks: 1, 2, 3, 4. So these vertical tanks are interconnected with each other, and these are represented as tank A, tank B, tank C, and tank D. These 4 tanks are interconnected with each other. Out of these 4 tanks, tank B contains cationic exchange resin. Tank C contains anionic exchange resins. These exchanges are fitted at middle of the tanks. So when you are passing hot water, through inlet provided at tank B, when you are passing hot water through the inlet which is provided at tank B, when hot water is percolates through cationic resin, so whatever cations present in the hot water be replaced by cationic resin. So now we know that what is the representation of cationic resin. How we can represent cationic resin? RH press. So when you are passing hot water through the cationic exchanger, so whatever cations present in the hot water removed by or replaced by H plus ion present in the cationic resin. So we know that cationic resin is represented as RH plus. So look at here. So RH when you are passing hot water into the cationic resin. So whatever cations, that is calcium and magnesium present in the hot water, so that is replaced by hydrogen present in the resin. So forms resin cations. Okay. So after removing cations, the same hot water is passes into another tank, that is C, tank C. So which contains anionic resin. So after removing cations, the water which contains anions only, that water is passes into the tank C. Here tank C contains basic resin or anionic resin, that is ROH. So when water which contains anions only, that water percolates through the anionic resin, so that anions are removed by basic resin or anionic resin. So look at here, we can see how anionic resin can remove the anions present in the hot water. So ROH, so this is the anionic resin. So when you are passing water which contains anions only, so what are the anions present in the hot water? Cl minus, SO4 minus, CO3 minus. So R2Cl. So OH, Cl minus ions are replaced by OH present in the anionic resin. So here OH is the anionic exchanger. Similarly, SO4 minus 2 and CO3 minus 2. So these are all anions removed by anionic exchangers. So this process continues for a few hours. After that, if you want to further purification, further removing, if you go for further removing of cations and anions present in the water, we cannot purify. We cannot remove the ions present in the water. Why? Because here in both cationic resin and anionic resins contains cations and anions of hot water. That means RCA, cations of hot water, or Cl minus, anions of hot water. So now these resins contains only cations of hot water, and anionic resin also contains only anion of hot water. So in this condition, we cannot go for further purification of water. So that's why whatever resins, that is cationic resin and anionic resins present in the operators, they has to be exhausted. How it will be exhausted? By following regeneration steps. So what is a regeneration? How we can regenerate acetic resin or cationic resin, basic resin or anionic resin. So let us see the regeneration of cationic resin first. How we can regenerate cationic resin present in the tank B? So by passing HCl by passing HCl solution which is present at tank A. So cationic resin is regenerated by passing HCl solution which is present at tank A. So what will happen? Let us see. So in this condition, cationic resin contain only cations of hot water. So when you are passing HCl solution, cationic resin will be regenerated. Similarly, anionic resin also has been exhausted. It also regenerated. How it can be regenerated? By passing alkaline or NaOH solution present in tank D. So from tank D, NaOH solution we are passes into the tank C which contains anionic resin. So let us see what will happen. So now anionic resin contains only anions of hot water. When you are passing alkali or NaOH into the anionic resin, basic resin will be regenerated. That is a ROH, basic resin. So these two steps are known as regeneration of resins. Why? Because in these steps we can regenerate both cationic resin and anionic resin. So cationic resin is regenerated by passing HCl solution and anionic resin is regenerated by passing NaOH solution. So these are the regeneration steps of ion exchange method. Now after regeneration, now we can go for further purification. Why? Because resins are regenerated. Resins are regenerated. Then we can go for further purification. So that is the procedure for ion exchange method. Now coming to the advantages of ion exchange method. This method can be used for IARE acidic and IARE alkaline water. That means water which contains high acidic in nature as well as high basic in nature. That water also we can purify by using ion exchange method. The residue hardness of water as low as 2 ppm. And very good water treatment method for high pressure boilers. And working of or operating of ion exchange method is very simple. And coming to the disadvantages, equipment is expensive. Why? Because here we are using resins to remove the hardness causing ions present in the water. So the cost of resins are too expensive. And turbidity. Turbidity of water should be less than 10 ppm. Otherwise, output will reduce. Turbidity needs to be coagulated before treatment and needs skilled workers for operating ion exchange method. So these are the disadvantages and advantages of ion exchange method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.